Hi everyone. Yeah. So today we'll be discussing about uh, one of the major changes into Android Jetpack. That is basically changes to the shared preference. Shared preference is something which is very much close to our heart because we have been playing with shared preference since the day of inception of Android. Uh, in this session, I'll be walking you through what data store preferences are and what are the different kinds of it. And also, at the last, we'll also see how we can migrate our existing shared preference to data store. Let me introduce myself. So, I basically lead the Android team at OLX. I am the chapter lead of the Android team at OLX Group. And today, we'll see how we can play with the data store preferences. At the end of this session, we'll be able to basically create our own data store preferences, and also we'll see a procedure how to migrate from the current existing one. So moving ahead, uh, so we'll be discussing about the introduction to Jetpack Data Store. Second, we'll go what data store has under the hood. Why do you need data store? And setting up the Android project with preference data store and the prototype data store, migrating from the shared preference to data store, and finally with the Q&A. Okay, so an introduction to data store, as the name suggests, it's a data storage solution. So it's a part of Android Jetpack and introduced in Android 11, and it's a data storage solution. It comes with two different implementation. One is basically it is the preferences data store that stores the key value pairs. So this you can think of a kind of similar to that we have currently right now in terms of shared preference. Second is the proto data store that lets us store type objects via protocol buffers. So if you're not familiar with the word protocol buffer, probably please wait for some time. I'll try to explain it in the upcoming slides. One of the major, topic of discussion is basically the Jetpack data store stores data asynchronously. It consistent and also the transaction is maintained. It's ideal for small, simple data sets and doesn't support partial updates or referential integrity. So this is all about the introduction. Under the hood, the data store and the proto, both the variants of the data store, they saves the preference in a file. So as compared to the shared preference, yes, it also uses a file, and it performs all the data operations on dispatchers.io unless specified otherwise. So as this is a kind of asynchronous operations, so and it is under the hood, it uses coroutine. So it uses dispatchers.io to perform all the data related operations. As far as saving data is concerned, preference data stores like the shared preference has no way to define a schema or to ensure that keys are accessed with the correct type. So it's not type safe as the same problem lies with shared preference. But in proto data store, it lets you define a schema. So in that schema, you can use protocol buffers, and it can persistently store data for you with a strongly data type. DataStore provides efficient, cached access to the latest durable persistent state. The flow will always either emit a value or throw an exception encountered when attempting to read from the disk. So DataStore also provides caching. So you can cache the results of the DataStore, and whenever you call the DataStore for the query, the DataStore for the latest state, it will emit as a flow. So under the hood, if you can see, it uses basically coroutines. For asynchronous operations, it uses dispatchers.io. And for continuously emitting the results, it uses the flow, coroutine flow. Now the question is, why do we need the data store? So the shared preference has been a very stable thing, and it is something that the developers fraternity know about. Yeah, if something has to be stored, store it in shared preference. So there are some major drawbacks of shared preference, which the data store basically the API try to overcome. Uh, so what shared preference does was basically it provides a synchronous API that is safe in disguise. So even if we call shared preference and the UI thread in a synchronous manner, it is actually a disguise because there is no mechanism for single signaling errors and it lacks the transactional API. Now, there may be the case you might have also observed, like what happens is whenever you used to store large data sets in a shared preference and used to call the shared preference to load the data for you, the large data sets for you, sometimes it might block the main thread and hence it is not a main thread safe and it becomes a source of ANRs. So it happens ideally with a large data chunk which you used to store in the preferences file, because ultimately it's a IO operations that shared preference does internally. Now, so what does DataStore have for us? So DataStore, as I discussed earlier as well, so it supports asynchronous API via Kotlin coroutines, and internally it uses the flow, and which is it's safe to be used on the UI thread. DataStore, it can signal errors and is safe from runtime exceptions. It basically helps us to save a lot of time in exceptions, and it provides a type safety. Proto data store, on the other hand, are comparatively smaller. So if we compare proto buffers with other formats, data formats like XML or JSON, it is comparatively faster. It is smaller, simpler, and it's less ambiguous. Also, it provides a way to migrate from shared preference. That's what we'll discuss as we go further into the presentation. Now it's time to see some part of the code, like as in how we can create our own data store and how to create our own proto data store in case if we need to store all those preferences that we have right now in our app in data store format. First of all, we'll discuss about the preference data store. So the use case that I will take is basically you might have seen in your development, like you might need to store the app launch time or probably app launch number of times your app is launched, and probably you save it in your shared preference. So this is a very simple use case, as you can see in the video, in a demo video. So there is a button, their screen is launched, and every time the screen is launched, it gives you the counter. So this counter, like when you come back and relaunch the screen again, this counter is retained, and this is being done by the preference data store. So as I've told earlier, preference data store is nothing but it's a key value pair thing that is to be done. So this use case fits perfectly to our preference data store. Setting up the dependencies. So we have the dependencies. Currently, the data store is in alpha, and the current release is alpha 03. But for the simplicity purpose, and also to avoid, because I have already developed the demo application is alpha 02. So we'll be demoing all this demonstration in alpha 02. And for dependencies, I personally prefer the lifecycle and live data support. So for that, you can you can add the lifecycle runtime as well as the lifecycle live data in your dependencies graph. One thing that you need to mention is basically the compile options, because there are some source compatibility issues. So probably you can add compile options as Java version 1.08 and also the Kotlin option as JVM target version as 1.8 for smooth compiling. Now creating the preference data store. So it uses the extension functions to create the data store, and to that extension function you provide the app preference. So this is in similar in sync with the preference shared preference that we create nowadays. We call the get preference method from the context, and probably we pass the name of the preference and also the mode that is being passed. So this is how we create the data store. And creating the preference key. So as in shared preference, you see, we create the keys as a flat strings, right? Now here, there is a strong, there is a preference key that you need to define, where you have a name, and for the sake of the demo, you can say it's an app launch counter, because we're going to save the app launch counter to our preference file. Now, writing to the preference data store, the increment app launch counter method, is basically uses the data store edit method, which basically takes which basically updates the current counter value of the launch counter. Basically, it queries the counter basically first of all, and after that it increases the counter, and it just similarly it puts the preferences to it. So as you can see, preference key app launch counter, current counter value dot plus one. Now, after you create your first data store, if you look into the Android device explorer in your Android Studio, you will see one file that is getting generated. So as I've given, it's like app preference name. So in the inside the data store, you will see there is a app preference dot underscore pv. So that is basically generated. Now, to read, it's a kind of simple, call to the preferences with the app launch counter. App launch counter is basically the key, and it maps the preference app launch preferences and get the key as a flow. So every key that you access, you get a flow to it, and inside the flow you get a type, and the caller of the basically the method is basically waiting on the particular flow. Again, like it's a kind of simple removing the key from the preference data store. So you simple go and probably preferences dot remove key app launch counter. So it's almost like the similar operations you can see as that we currently do in shared preference. So I think till now you might have got a very good hint, this preference data store is something that is very easy to migrate. Yes, you are right. So now, whenever some client want to utilize this particular method or probably read the data store, so what the client can do is basically directly observe the flow, and whenever the flow has some data, it emits the data and it's ready for the client to use it. So as you can see, we have observed the flow as a live data, and inside the live data there is an observer, and whenever there is any data in the particular flow, the data basically is readily available to the client. Coming next to the second type of preference data store, that is basically the prototype data store. So it started with the naming started with the proto data store, and now in the Google guidelines you will find is a type data store. So in the demo, the use case that I will discuss is basically a list of you can say items, and for the sake of simplicity, that there is a kind of different item type. So I have considered this as a kind of add or classifieds, probably a classified list. And inside the classified list, you will see there is a free, there is a category. So the one in the dark teal, basically suggests it's a free ad, and one at the the teal color shows the category. So at the bottom you will see some spinner that basically denotes the filter that you need to apply on this particular list. Now most of the guys, I have discussing this prototype data store. So most of the people, I think, since it's a protocol buffer, probably we can store a list to it and all this like that. So but what it suggests, so what DataStore suggests is basically DataStore is something that needs to be manipulated as simply as you can. So as you can see in the use case, I have used to store only the filters. So filters as in Like one can select a filter of a particular category or probably the type of ad. So whenever user will select a particular filter, that filter is basically preserved in the proto data store, and after relaunching of the app again, the filters are basically retained. So this is a particular use case that you can consider while you go with a prototype data store. Moving next, so what are protocol buffers? So protocol buffers are Google's language neutral, platform neutral, extensible mechanism for serializing structured data. So there are various ways to store structured data in form of XML, in form of JSON, but protocol buffers are basically it platform agnostic, it language neutral, and they are extensible. They are basically extensible, and also like the extensible mechanism. They are extensible mechanism for serializing all those structured data. Protocol buffers currently support generated code in Java, Python, Objective-C, and C++. So it has a wide, range of utility. So and also at a cost of its speed as well as reliability and also the size, the protocol buffers stands alone. So because protocol buffers are very light and they're very fast. Now, to work with Proto Data Store, you need to actually do a lot to the Gradle file. You need to set up your Gradle file to support the proto buffers and also to be used in your proto data store. So three things you need to do. One, you need to add the protobuf plugin. Second, add the protobuf and proto data store dependencies to it, and configure protograph to generate class for the serializer. So I will try to explain those serializer thing and all the stuff in the immediate slides. So for now, if you talk about the Gradle dependencies, so you need to apply, you need to basically apply a protobuf plugin at the top of your module. Uh, Inside the dependencies, there is a DataStore core 1.0.alpha 2, that is the version, and latest version is basically 03, as I mentioned earlier. So for Proto Data Store, you need to have this dependency. For Protograph, you need to have this implementation in your dependencies. Now, to configure Protograph to generate classes for the serializer, so once you define a particular proto for your preference, that proto needs to be converted to a Java file, and that goes as a type to your serializer. So I'll let you know what the serializer is. And this is basically the standard of how you generate protos from your proto file. Moving ahead, how to define the proto file. So there is specific guidelines to design a proto file. So you can go to the official guideline of proto buffers, and there will find different syntax and probably what are this language equivalent data type. Now, as I told you, I am using the protobuf proto data store for storing the filter for the particular list. So my filter can be of basically can consist of two things. One is basically the ad type. Ad type is basically either it is a free or a paid, uh, or probably it's a kind of unspecified. That means it's a kind of all ads or all type of ads. Second, it can consist of a ad category, right? So as you can see in the proto, there is a way how to define a proto, and there is you start with the syntax where it states a proto 3 version proto 3. Java package is basically the package inside which you want your proto classes to be generated. So once you define a particular proto file, and when you rebuild your project, when you basically make your project, then yeah, auto generated class you will find, and that auto generated class will be inside this package. One thing that you need to mention, one thing that you need to notice is basically you need to define a directory at parallel to your main folder in your project to be basically available for your proto files. So there is an app source main, and inside the main you have a proto along with your Java directory. Inside the proto, you define one proto file, and therein you define what kind of preference proto you will basically store. And this particular ad type, so whenever it starts with a message, it starts with a keyword message, and whenever it sees the proto basically the the compiler, basically the compiler sees a message, it generates a proto class for it. So add type is basically a type of the add type, and it starts with base 1. So this can range from 1 to 1 to over 29 minus 1. So these values. There is add type, there is add category, as you can see. So coming next, like whenever you are done with the proto like file, probably you can build your project. And as you will see that add filter preference, so the same name as you have provided next to the message keyword will be generated at compile time. Now creating the proto serializer. So serializer are basically you're telling the data store how to read and write your data type. So you have defined a proto, and inside the proto you have defined all those message and all those type of the variable inside that proto. And that serializer will basically tell you that how you will read and write. So it's a normal kind of read from and write to as a normal serializer thing. So this is something that you need to mention as a serializer. Creating the proto data store. So in the previous one, you saw like we created data store with a file name only. Here you provide a serializer because you want your proto to be read in a particular format and write in a particular format. So you need to provide the serializer as well. So this is how you declare the proto data store. Writing to the proto data store. Uh, Whenever you write to the proto data store based on the add type. So let's suppose I've selected an add type, and whenever the type comes, you basically assign the add type to a particular add type generated add type of the proto. Similarly, like whenever your add type, you just give it the add type, and basically whenever you update, you just call the update data, and update data inside the update data, you just create a builder. So this preferences is basically the proto file that is created, and inside that you will see a builder, and that builder will give you the serializer object, and inside the serializer object you will find a builder method set at type, and you can set like that. So this is how you write to the proto data store. After you write some like input to the proto data store, you will see another file that is generated, that is basically the add list preference.pb. That is in parallel with your app preference that we have created for preference data store. Now how to read from the proto data store. So whenever you read, it will return you a flow, as the data store is basically supporting flow for returning all the values. And this is how you basically read the data. You iterate on the data store data, and probably you see if it's an add type, then probably finally you have that add filter category with the type. So this add filter is something that is mapped to your UI model. So you are expecting something from the UI model, and you are filling the UI model from the data store. So that's how a client will read the add filter. So add filter as live data observe, and whenever it observes, it gets the add filter as a flow. And whenever the filter changes, it gets a callback to this observer. And whenever this particular method is invoked, the list is populated, as you have seen in the demo. Now, one of the major topic that basically leaves us is basically the migration. Now, yeah, so we have been using shared preference since long, and now the data store has come. So now how to migrate? Uh, for migration, so one of the beauty of data store is basically they have provided a shared preference migration object to the data store builder. So whenever you want to migrate your existing shared preference, you simply use the shared preference migration object, and it does the things for you. One thing that you need to notice is basically migration is basically should have succeed before data store data returns any value, and update data is method is called. So basically migration is basically a type of, you can say, initial step that you need to do before you access any particular data from that data store. And once you have migrated from shared preference, you need to be cautious that you don't use that particular shared preference, because what it does after the migration, it basically it deletes the previous preferences files. So how to migrate? So as you have seen, we have created a data store while storing the data. Similarly, like whenever you are basically that till now we have discussed, like whenever you will basically want to use the data store for storing the data in a very greenfield project. Now for apps which are already into shared preference and which are already using shared preference heavily, so how they will define a data store? So they will basically provide some migrations. So list of migrations can be a lot of migrations. So there can be a lot of preferences files. A project can have a lot of preferences files. So you need to provide a list of preferences file to it. And this migration happens at the background. And this migration will do it for you. So keys and everything are migrated, and the shared preference files are deleted after the migration is over. Now, like there might be some case where, let's suppose the same filter use case where you're saving the filters selected by the user, and while populating the list. So how to migrate those shared preference to pro data store? Now we know we have a filter preference, and that filter preference is basically having the add type and the add category. So in the shared preference, you might be having in your previous app, your shared preference might be having an add type and it might be having an add category that you're already saving. Now we need to migrate those preferences values, or probably in form of some strings or probably some integer values, and to the protograph. So like you might have got the gist that you need to have a kind of mapper. So while migrating shared preference to proto data store, you need to create a mapper. So that mapper is basically nothing but a mapper of your existing preference string. So as you can see, I have mapped shared preference get string old add type filter key name, default value type all, to the particular builder. That builder is basically generated by the the protograph, the protos. So I've mapped the existing shared preference to my protos. So this is how you create a shared preference migration mapper. And second is basically creating the data store, defining the data store object. So inside the data store object, you can see we have a file name, we have the serializer, same serializer, and the list of migrations. So migration is basically the mapper that you pass to it. So shared preference migration object along with the mapper. So pass the mapper to the serializer and create the data store object. Now, there might be a question like, yeah, so we have been using the shared preference in asynchronous code, like we directly read the values, because since shared preference is meant to store key value pairs, and I want to access it at the UI thread. So now, since data store comes with a package of asynchronous API, now how can I rely on that? Because I need my code to run in a synchronous manner. So there is Kotlin run blocking coroutine builder, which you can use to basically access the keys directly in a synchronous manner. But the problem with this is basically don't rely heavily on this because blocking will actually block your UI thread. So there is another kind of methodology is basically the asynchronous preloading. So what you do is basically you pre-cache, you initialize the data store, you pre-cache the data, and after that you synchronize your IO operations. So like this, what will happen is basically whenever you're pre-caching the data, as I have told earlier, data store also comes with the caching mechanism as well. It has the caching mechanism. So you cache the data, you initialize the data store, you cache the data. After that, you can use run blocking, and probably you can have the initial read in a very faster manner. So this is how you can expect a kind of synchronous code. So now, we have gone through all those data store definitions, as well as how we can migrate to data store. And yes, it's time that we say hello to data store and bye to our old shared preference. Those are some references. So, and the developer side, and if you want to look at the demo that I presented here, you can feel free to go and contribute to the GitLab repo. And also, have a look at the protographer document that will basically give you an idea, how to define proto buffers for you. And yes, so these are okay. So this is me, Hitesh, and I'm a technical architect for the Android chapter at OLX, and therein I'm leading a team of around close to 15 to 18 members, and also in collaboration with Berlin Hub as well, India and Berlin Hub as well. You can find me on email. You can tweet. You can tweet. I'm available on Twitter. I'm available on LinkedIn. So yeah, I think we can open the questions right now. Yes. Okay. So the first question, yeah. So is it possible to encrypt data in shared preference by using encrypt with shared preference? Is it similar way to encrypt data with data store? Yeah, you can use the encrypted data with data store, but with proto data store, I'm not sure, but yeah, definitely with preference data store you can use the encrypted data store, that is for sure. But for proto data store you need to see, because it comes with a type, and whenever you encrypt, probably while the deserializer happens, probably you need to decrypt that. Yeah, I think you need to play something with the decrypt. You need to play with the serializer, because serializer is the one who is responsible for reading and writing the data. So I think on a similar ground of shared preference, you can use that. Yeah. Uh, yes. So coming to the next, can I use RX in place of coroutine? So data store, basically under the hood, it uses coroutine. So it's not like you have the choice to basically have a kind of RX handling under the hood. Under the hood, data store uses coroutine because it's a kind of coroutine first, you can say the back thing, back like backing thing that comes with data store. But definitely you can play with the threads. Probably you can because you can play with the RX plates in the client, because you can observe that thing. But inside data store, it's always coroutine. Yeah. Yes, I think we can move to the next. In terms of multi-process access, is there any improvement compared to shared preference? Okay, so multi-process access, I think it's thread safe, because earlier it was in shared preference, it was not, but yeah, it is thread safe. Um, is there any encrypted data store, or would you need to do that shared preference? Yeah, I think in multi-process access, yeah, it's thread safe. But is there any improvement compared to shared preference? I think in terms of thread safety, it has to be. But yeah, I need to check on this. We can go to the next. Do the migration have to happen at all once, or they can be done separately for each preference file? Yeah, so migration has to happen at all at once, that is for sure, because after your app is initialized, and probably you need to use the shared preference, or probably you need to modify the shared you need to modify those preferences, right? So the migration process is similar to as that of any migration that you have. So migrations need to be happen at once, and separately for each preferences file, it will depend on because what happens is, basically when you create the data store object, you pass a list of migration objects, right? So you can't redefine the data store object every time, so it has to be go at one shot, and you list down all those mappers to your preferences, and you just provides the mappers to it. So so my answer to this will be yes, you need to do it only once, and it has to happen in a single go. Yeah, I think we're done. Yep. Thank you very much, guys, for attending this, and hope you enjoyed, learning something new. And do connect me over LinkedIn, Twitter, anything that you want to ask regarding this. I will also update on the the repo that I've shared. Do feel free to contribute. And yeah, uh, happy these 2 days, like, happy DroidCon.